Researchers at Nvidia recently released a paper titled Voyager, an open-ended embodied agent with large language models. The groundbreaking paper details how Nvidia's team of researchers were able to create an open-source GPT-4 powered autonomous learning agent whose sole mission was to explore the world of Minecraft, acquire diverse skills, and make novel discoveries without human intervention. It is essentially a tailored and more powerful version of the famous Auto-GPT model, whose core directive is to be the best at Minecraft. The important question though is, why was an Auto-GPT for Minecraft created? In the paper introduction, the researchers say that building generally capable embodied agents that continuously explore, plan, and develop new skills in open-ended worlds is a grand challenge for the AI community. And goes on to say that despite these agents being deployed to embody tasks like games and robotics, they are not lifelong learners that can progressively acquire, update, accumulate, and transfer knowledge over extended time spans. Meaning there is a limitation imposed on these AI agents by the game or system that they embody, and therefore are confined to the predefined end goal of that system. An exception to the rule of a system with predefined end goals though is Minecraft, which requires players to explore vast procedurally generated 3D terrains and unlock a tech tree using gathered resources. Sidebar. A tech tree is like a roadmap that shows you different paths and options to upgrade and unlocks new abilities or items as you progress in a game, say Minecraft. It's a bit like leveling up, but instead of just getting stronger, you get to choose how you want to grow and what stuff you want to unlock next based on your preferences and playstyle. The paper then says an effective lifelong learning agent should have similar capabilities as human players who can 1. Propose suitable tasks based on its current skill level and world state. Example, to learn to avert sand and cactus before iron if it finds itself in a desert rather than a forest. 2. Refine skills based on environmental feedback and commit mastered skills to memory for future reuse in similar situations. For example, fighting zombies is similar to fighting spiders. 3. Continually explore the world and seek out new tasks in a self-driven manner. So, with these goals in mind, Voyager was created as the first large language model powered embodied lifelong learning agent to drive exploration, master a wide range of skills, and make new discoveries continually without human intervention in Minecraft. This sounds really cool, but how does this agent Voyager work? Well, you see, Voyager works through 3 key components: an automatic curriculum for open-ended exploration, a skill library for storing and retrieving increasingly complex behaviors, and an iterative prompting mechanism that generates executable code to control its actions. Voyager interacts with GPT-4 through prompting and in-context learning, an approach which the paper says bypasses the need for model parameter access and explicit gradient-based training or fine-tuning. More specifically, following its first key component, Voyager attempts to solve progressively harder tasks proposed by the automatic curriculum, which is generated by GPT-4 based on the overarching goal of, say, discovering as many diverse things as possible, similar to the primary directive given when using Auto and Agent GPT. Here is a brief example of tasks proposed by the automatic curriculum, showing the reasoning Voyager uses to take action on a task like catching a fish, and how the difficulty and type of task is influenced by the previous action and the agent's current state. For its second key step, the paper explains that Voyager incrementally builds a skill library by storing the action programs that help solve a task successfully. Further saying that each program is indexed by the embedding of its description, which can be retrieved in similar situations in the future. This method of reasoning and approach to learning compounds Voyager's ability rapidly over time and alleviates catastrophic forgetting that's present in other continual learning methods. Lastly, to combat the shortcoming of LMs in producing the correct action code in one shot, Voyager applies its third key component with the iterative prompting mechanism in the following steps. First, executes the generated program to obtain observations from the Minecraft simulation and error trace from the code interpreter if any. then incorporates the feedback into GPT-4's prompt for another round of code refinement, and subsequently repeats the process until a self-verification module confirms the task completion, at which point we commit the program to the skill library and query the automatic curriculum for the next milestone. This is basically chain of thought with self-reflection prompting technique happening in real time inside the world of Minecraft, which I think is insane. Some experiments run by the researchers leverage OpenAI's GPT-4 and GPT-3.5 APIs for text completion, with a simulation environment built on top of MineDojo, leveraging MineFlayer's JavaScript APIs for motor controls. Sidebar, what is MineDojo and MineFlayer? Well, MineDojo, founded by researchers at Nvidia, is a new framework built on Minecraft for embodied agent research, featuring a simulation suite with 1,000 of open-ended and language prompted tasks, where the AI agents can freely explore a procedurally generated 3D world with diverse terrains to roam, materials to mine, tools to craft, and structures to build, and more. However, MineFlayer is a pluggable Node.js library for creating Minecraft bots, which provide a high-level API that allows developers to write bots that can interact with the Minecraft game world. Because there's little available LLM-based agents that work out of the box with Minecraft, the researchers reinterpret agents like React, Reflexion, and Auto-GPT to be executable in MineDojo, so it's compatible with the experimental settings and usable as a baseline. Compared with Voyager, Auto-GPT lacks the skill library for accumulating knowledge, self-verification for assessing task success, and autocurriculum for open-ended exploration. In the comparison, React and Reflexion, two agents which use chain-of-thought prompting and were provided by the research team with environmental feedback, execution errors, and self-verification modules, failed to unlock a level of the tech tree, despite being put through the maximal prompting iterations of 160 times. Auto-GPT, in comparison with Voyager without a skill library, managed to unlock several levels of the tech tree, like building a wooden tool, building a stone tool, and an iron tool. Auto-GPT and Voyager without a skill library both failed at building a diamond tool, and it took Auto-GPT about 90 to 130 iterations out of 160 to pass the experiments, whilst taking Voyager without a skill library significantly smaller attempts ranging from 2 to 29 out of 160. Voyager with a skill library, however, which is the one that is being covered in this paper, come out on top, passing the experiment in generally less iterations, and was the only agent able to make a diamond tool at least once. The paper covers other experiments and results, showing leaps in abilities of the Voyager covered in the paper against the modified agents like Auto-GPT used as baselines. In conclusion, Voyager is so impressive that despite not currently supporting visual perception due to a GPT-4 text-only limitation, it was able to construct complex 3D structures in Minecraft such as the Nether portal and a house from human feedback. Voyager does have some limitations, and one that I have repeatedly covered on my videos about research papers is cost, especially on papers using GPT-4 APIs, which is 15 times more expensive than GPT-3.5. Nevertheless, Voyager requires the quantum leap in code generation quality from GPT-4, which GPT-3.5 and open source LLMs cannot provide. The problem with AI hallucination still exists in GPT-4 and Voyager in tandem. For example, it may ask the agent to craft a copper sword or copper chestplate, which are items that do not exist within the game, amongst other code generation issues. Let me know what you think about Voyager, and if you'd like to try it, there's a link in the description and a link to the paper so you can check it out for yourself. Check out this video on the Tree of Thought paper that is prompt engineering GPT-4 to think like humans. Thank you so much for watching and have a great day.